In this video, we will actually talk about multiprogramming and multitasking, specifically time sharing systems. That means we will discuss the main ideas of multiprogramming and multitasking systems. Okay, so let's first look at multiprogramming systems. So multiprogramming systems, the idea of multiprogramming system actually comes from the idea of CPU utilization. That means CPU should not sit idle. CPU utilization should be maximized because CPU is one of the important resources of a computer system. And multiprogramming is often termed as batch system. And the main idea, as I said earlier, that the main idea is keeping CPU and input output devices busy. It means we want to maximize their usage. And then the idea will be that there will be lots of processes in main memory, so that CPU always get one process to execute. So I have already said that many processes will be actually kept in main memory, and CPU can take one out of these processes and execute. The way actually CPU does it is called job scheduling. So job scheduling is completely a different concept used by operating system to pick one process out of many processes that are waiting in the main memory. When operating system needs to allocate CPU to other process, operating system actually switches to another job. Now let's talk about a new concept called multitasking. In other words, it is called time sharing system. Please note that in multiprogramming, we are not referring to multiprocessor systems, and also in multitasking and time sharing systems, we are not referring to multiprocessor systems. I understand it is often confusing that if multiprogramming and multitasking are referring to multiprocessor systems. No, here we are exclusively talking about uniprocessor systems. I understand processors can support multiple processes, so that obviously be multitasking. But here, for our today's discussion, we are only focusing on uniprocessor system. That means we have only one processor where we want to implement multiprogramming concept and multitasking concept. So now let's talk about multitasking, and then we will come back to clarify with an example. So the main idea of multitasking is concurrent execution of multiple jobs. What is the major difference from multiprogramming? Multiprogramming, the main focus was on using CPU efficiently. It was not a matter if one process waited for a long in multiprogramming. But in multitasking or time sharing system, all the processes must be serviced in a way that it gives an appearance to its users that all the processes are actually progressing. All time sharing system is a logical extension of multiprogramming because the CPU switches back and forth from one process to the another process, and it gives a feeling of interactive computing. That means multiple users will have the feeling that their processes are progressing. Here we are considering uniprocessor system. Uniprocessor system, that means we have CPU for our convenience. Okay, so now we'll see that we have one process P1 needs 5 millisecond CPU time, and then 3-second input output, and then again 4 millisecond CPU time, and then 2 millisecond input output. P2 P2 needs 4 millisecond CPU time, and then 2 millisecond input output time, and then 5 millisecond CPU time. Okay, so how a single processor can support these two processes using multi-programming concept. So let's assume that P1 and P2 submitted to the system arrive around the same time in the system. Let's assume that out of the 1 and P2, P1 is picked by the operating system to allocate the CPU first. So we have CPU allocated to P1, and then P1 will run for 5 milliseconds, and then it will go for input output. So this is input output, and this is, and then P2 will wait. P2 here wait, and then when the first process will be doing its input output, it will actually use the CPU. It will use the CPU for 4 milliseconds, right? 4 milliseconds. Okay, so after 4 milliseconds, it will go its input output. And so this is the idea of multi-programming. As we can see, that CPU is always being used, right? So there is no point of time where CPU was not being used. So that is the idea. So multitasking will give completely different feeling, that every user's process is running. Maybe they are running slowly, but still they are running, right? So please note that this multitasking system can be implemented by multiprocessor systems, but here we are only talking about time sharing or multitasking in uniprocessor systems, right? Now, say you have two processes, P1, it needs, and let's consider another process, P2, who it needs 4. That's it. That is what it needs. So let's see how operating system will satisfy these two processes requests. Initially, P1 and P2 both were submitted at the same time. Let's say operating system first picks P1. So based on time sharing scheme, the operating system will allocate a fixed time slot for each of the processes. Let's say that time slot is 1 millisecond, for example. Say operating system picks P1, so it will run 1 millisecond CPU, and then P2 will wait during this period, and then P2 will start, the P2 will start using CPU for 1 millisecond. During this period, P1 will wait. After a while, we know that P2 will need input output operation after 4 milliseconds, right? So during this first 4 milliseconds, it will switch back and forth between P1 and P2. But after 4 milliseconds, we will see that P2 will come for input output for 2 milliseconds, right? So during this 2 milliseconds, there is only one process in the system, that is P1. So P1 will completely use that 2 millisecond CPU. Okay, and after that, again, you see that actually after 5 milliseconds, it will again need what? It will again need, during that input output, right? So it may not use the full 2 millisecond, it will use only 1 millisecond, right? Okay, 1 millisecond, so it will come for the input output. So this is the idea. Actually, it will give the users a feeling that all the processes are progressing and no process is waiting for another process to get the CPU for a long time, right? So that is the basic difference between multi-programming and time sharing, and it should not be confused with multiprocessor systems. So I hope it makes things clear that multi-programming actually enhances CPU utilization and multitasking actually enhances user experience. I hope it makes things clear, and thank you so much.